6 lines of optimized plan, and your Python and your SQL produce the same 6. I diff them, measured on this machine. Identical except the expression numbers Spark hands out. Same filter, same aggregate, same scan, and the same 8 rows back. So when both sides ask for the same built-in operations, the language is a readability decision, not a performance one. What does bite is where your views and tables live. Today, Spark SQL, views, tables, the Metastore. Here they are, side by side. Your DataFrame chain, filter, group by, count, order by. Your select with a where and a group by. 2 different texts and 1 plan. Sort, aggregate, project, filter, scan. The only characters that differ are the numbers Spark attaches to each expression. Episode 2.6 of the course. The next one is where a choice finally costs you, so subscribe. Now, where does that SQL find your table in the first place? Nobody pays a tax for typing select, and nobody gets a medal for typing Python. Both descriptions reach the same analyzer, resolve to the same logical plan, and hand catalyst the same thing. So when the 2 sides express the same built-in operations and land on the same optimized plan, syntax alone is not what moves your cluster bill. The argument in your team is about who reads the code in 6 months. A user-defined function or a hint can still change the plan. The keyword you typed cannot. Write the aggregation in SQL when SQL reads better, and in Python when Python does. This is where they meet. Your SQL text gets parsed into an unresolved plan. Your DataFrame calls build that plan directly, no parser involved. From there, they follow the same road. The analyzer resolves the names against the catalog, the step that decides whether the word logs means anything. Then the optimizer rewrites the plan, and only then does Spark pick a physical plan. 2 doors, 1 pipeline, which is why the 6 lines came out identical. And the catalog in the middle is the thing you're really configuring when you create a view. A temporary view is how your DataFrame gets a name in SQL. Create or replace temp view logs, and now you can select from it. But open a second session in the same application and ask for the same name, table or view not found. Your view is scoped to the session that made it, not to the cluster, not to the application. A separate SparkSession cannot resolve that name at all, and whether 2 notebooks share 1 session is a decision your platform makes, not Spark. The fix is a global temp view, and it comes with an ambush. Created globally, the second session sees all 40,000 rows, as long as you qualify the name with global_temp. Now define that same view over a session local view instead of over the DataFrame. In this local run, on PySpark 4.1.2, the second session gets table or view not found, and the name that's missing is the one inside the body. The view is global. What it reads is not. Views name a query. A table names data. Create table using Parquet as select gives you a managed table. Created here in 1.19 seconds. For files on disk, 935 bytes, and an entry in the catalog. Managed is the word that matters. Drop that table and your data directory is gone with it, which I ran, and the directory was gone. An external table with an explicit location keeps its files when you drop it. So which of these survives? Your session prints its catalog implementation, and on a plain local Spark it says in memory. The catalog lives inside the application, and nothing writes it down. Your table names die with the process, even though the Parquet files stay on disk. A persistent Metastore keeps that same metadata outside the application, so other sessions and compatible tools, pointed at that Metastore, can resolve the same table. That's the difference between a table you can query tomorrow and a folder you have to remember. So here's the rule. Same plan means you pick the language your reader needs, not the one you think is faster. Temp view for your own session, global temp view when another session needs it. And make sure what that view reads still resolves over there, because a session local name will not. Manage table when Spark owns the data, external when something else does, because drop means different things to each. And check your catalog before you promise anyone the table will still be there. Next episode, user-defined functions and the measured cost of dragging your rows out of the JVM and into Python.